This is the interim presentation for ISD 528 from Team 16, Analysis and Redesign of an Automatic Pet Feeder. An automatic pet feeder allows the pet owner to fill the container with the preferred type of dry pet food and pre-program the feeding schedule into the device. The feeder will dispense the required quantity of food at each pre-programmed time without interaction from the owner. The primary customers for this type of product are cat owners looking for a consistent and convenient way to control their pet's food intake. The secondary customers are dog owners, kennels, pet hospitals that can use a variant of this product to accommodate different food sizes and amounts. The estimated yearly demand for this type of product is around 500,000 units, and the estimated production volume for our product was estimated to be around 100,000 units. The core function of the pet feeder is to nourish your pet. The key functional requirements are to contain food, to deliver meal, meaning it must position the food in the right space, portion it for your pet, and dispense it to the bowl for your pet to eat it. It must be convenient for the owner, meaning it must be easy to sanitize or clean and easy to refill. It must be dependable, meaning the outside housing must protect internal components from damage from the pet. It must offer potential enhancements to the product, being able to adjust the portions or report the capacity, how full the container is to the owner. And it must please the senses of the owner, therefore it must blend in with the rest of the decor.
There are two proposals for assembly that we will walk through, shown in the fishbone diagrams. The first assembly sequence starts with the housing, continuing with the communication PCB. The flywheel and flywheel housing subassembly is then added, followed by the motor mount and motor. The feeder chute is installed, and then the subassembly of the bowl, faceplate, digital display, and control board is installed. The assembly is finished off by installing the supply flange and storage container. For the second assembly sequence, we start with the housing and then install the subassembly of the motor and motor mount, followed by the communication PCB. The flywheel housing, feeder chute, and flywheel subassembly is then installed, followed by a subassembly of the faceplate, control board, and digital display. This assembly sequence is finished off by installing the supply flange, storage container, and bowl. Sequence 2 is preferred to Sequence 1 as it has a better rating in ease of locating parts, ease of joining fasteners, and ease of assembling in parallel.
This is our function component mapping matrix. You can see most of our components have at least two functions associated with them. I note that most of the components have some relation to dispensing food or portion control of some regard. The other components that don't support these two areas do support various functions as captured on the FAST diagram, and we've shown them here.
The exploded view is shown here and consists of 14 unique parts, including fasteners. The bomb will be shown on the next slide. This slide shows the automated pet feeder bomb, which consists of plastic injection molded and blow molded pieces, metal die cast parts, as well as purchased electronics and fasteners. The total unit cost of the assembly is $40.20. Comparable automated pet feeders on the market range from $40 to $100. So our product design is on the lowest end of the range and is roughly 60% of the retail price of a similar feeder in the middle of the price range.
This is our quad chart based on the functional importance and manufacturing costs. From this chart, we expect to eliminate or redesign the faceplate supply flange, as well as the feeder housing, feeder chute, and motor mount. Most likely, we won't modify the motor or display or control PCB as these are purchased sub-assemblies.
Now we're going to discuss the product family design. After comparing the functions on the FAST diagram with our primary and secondary customer groups, only one function needs to be different, and that is adjust portion size. This is because the secondary customer group could have larger animals, which would require the ability for larger portions. The unique modules that relate to this function are the storage container and the food bowl. These modules would be able to contain the equivalent day's supply of kibble as well as present different portions of food to different sized animals. Although the supply adjustment would be set by a common digital display that would control how many times the motor turned the flywheel, this component can remain common to the platform.
The first interface for the secondary product is the supply flange that connects the storage container to the housing. The secondary storage container is much larger, but still threads into the flange the same as the blow molded bottle in the first design. The second interface for the secondary product is the slide mechanism on the faceplate to control the location of the food bowl. The secondary food bowl is much larger, but still slides into the flange as the smaller bowl, ensuring it is in the correct location when food comes out of the feeder chute. The assembly sequence for the original design can be modified to install the variant parts last, hence saving time, cost, and complexity of in-process assemblies. Thank you.